Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering. In today's class, we are going to discuss and we are going to solve some numerical problems based on the superposition theorem. In the previous class, we have discussed what is superposition theorem and the procedure to apply the superposition theorem to find the response across any element in a given electrical circuit. So in today's class, we are going to solve some numerical problems. We are going to apply the superposition theorem to the various electrical networks to find the response across a given element. So first problem is for the figure or the electrical circuit shown in figure, find the current flowing through the 20 ohms resistor. So here the 20 ohms resistor is here. So we have to find the current flowing through this 20 ohms resistor. Let us consider here it is I. So we need to find the current flowing through this 20 ohms resistor by using the superposition theorem. So as we know, according to the superposition theorem, so we should consider each source at a time and the remaining sources should be replaced with their internal resistance, which means here the voltage source and current sources are there. Here one voltage source and one current source is there. So suppose let us consider in case 1 only the voltage source and then the current source must be replaced with the open circuit. And in the second case, we must consider only the current source. So in that case, the voltage source, which must be the open circuit. Okay. So short circuit. So this is the way we are going to apply the superposition theorem. So first let us draw the first circuit to find the current flowing through the 20 ohms resistor. So first let us consider only consider the 20 volts source as active. Okay, so that here the 20 volt source as an active source, so that here then the circuit will become here as you can see here the 20 volts and the resistor here it is 5 ohms and here it is again 10 ohms and here it is again 10 and here it is 20. So this is 20 volts and this is 5 ohms and here it is 10 ohms and here it is again 10 ohms and here it is 20 ohms. So let us consider here it is case 1, right? So in this case, let us consider here the current flowing through this 20 ohms resistor is, let us consider I1. Okay. So here, then now we need to find the current flowing through this 20 ohms resistor. Of course, there are various methods are there to find the current flowing through this 20 ohms resistor. The one way is we can find the total what is that current flowing through this source, okay, which is 20 volts. And then after that, by applying the current division rule, we can find the current flowing through this 20 ohms resistor. And another one is by simply applying the loop analysis. And another one is by simply applying the nodal analysis. So here, I am applying the nodal analysis for this particular case. Okay, or simply, I am applying here, okay, the KCL, okay, to find the current flowing through this 20 ohms resistor for this particular network, right? So for this, here, first here, let us consider here the voltage is V1, right? So V1 minus 20 by here the resistor is 5 ohms, okay, and again plus here this current, and in the 10 ohms current, what is that, the current flowing through the 10 ohms, so V1 by 10 and plus the current flowing through this the series combination of 10 ohms and 20 ohms, so here it is again V1 by what is that, 10 plus 20, okay, which is equal to 0. Then by solving this, we will get V1 which is equal to 12 volts. V1 which is equal to 12 volts. Okay. Then the current through this 20 ohms resistor, here it is this one. This is the current through 20 ohms resistor. Okay. So that is I dash that we have considered, or I1 that we have considered. So here I1 is equal to V1 here it is 12 by 10 plus 20, then which is equal to 0.4 amperes, right? So here I1 is equal to 0.4 amperes. This is I1 in the case 1. Then similar way, in the second case, let us consider the case 2. Let us consider here case 2. In this case 2, we are taking the current source, which is 4 amperes, okay, as an active source, so that the circuit will become, here the circuit will become again the same resistors, and the voltage source that we can replace with the short circuit. So here it is a short circuit, and in between these two, 10 ohms resistor is there, and here it is 20 ohms resistor is there. Then again here the current source that we are considering here in this case, right? So here it is 5 ohms, 10 ohms, again here it is 10 ohms, and this is 20 ohms, and this is the current is 4 amperes, right? Okay. So in this case, now we need to find the current flowing through the 20 ohms resistor. Okay. So which means, let us consider here, this is the terminals A and B. Okay. So here the total resistance, what is that, of the across the AB terminal, here it is. So 5 and 10 are 5 and these 10 ohms are parallel. This 5 ohms and parallel with this 10 ohms, and this combination is series with this again the 10 ohms. Okay. So this is RAB, right? So that here RAB, that we can write as RAB is equal 5 into 10 by 5 plus 10 plus 10. So which is equal to 40 by 3 ohms. Then this circuit can be redrawn by replacing the equivalent circuit across the A and B. Here it is. And again here the current source is there, which is 4 amperes. And here, of course, here A and B that we are considered the terminals. In between A and B, this total equivalent value is, here it is 40 by 3 ohms. And again here it is 20 ohms. So let us consider in this case the current flowing through this 20 amperes is, let us consider I2, right? And here it is the current, total current. Then by simply applying the current division rule, okay, so by applying the current division rule, here apply current division rule, then here that the current flowing through this 20 ohms resistor I2 is equal to the total current, here it is 4 amperes, into the opposite resistance. The opposite resistance here it is 40 by 3 by the total resistance, here it is again 40 by 3 plus 20. Then the value of I2, here it is the value of I2, which is equal, if you simplify this, then you will get I2 is equal to 1.6 amperes. I2 is equal to 1.6 amperes. Then as we know, according to the superposition theorem, the response across any element is equal to the sum of the responses, or the sum of the responses by considering each source separately. So which means here the total current I, which is equal to I1 plus I2. Okay. So which is here in the previous case I1 is 0.4, I1 is equal to 0.4 and I2 is equal to 1.6. Okay, so therefore here it is 0.4 and 1.6, here it is 2 amperes. So here the current flowing through this source is 2 amperes. So this is the way we can apply the superposition theorem, right? So in this case, one voltage source is there, one current source is there. So the voltage source should be replaced with the short circuit and the current source should be replaced with the open circuit, right? Okay. Then let us go with the another problem, right? So in this case, we are having two voltage sources, because in the first problem we are having one voltage source and one current source, and in this case we are having the two voltage sources. Okay, then in this case, how to apply the superposition theorem? And in this case, we need to find the current flowing through these 1 ohm resistor. So let us consider here it is I, right? So first let us consider case 1 again. Case 1. Okay, so in this case let us consider only the active source is 130 volts. The active source is 130 volts. So then the circuit in the case 1, it is like this. So 130 and again here. So here the 110 volts is replaced with the short circuit. Then this is the circuit, and here it is 130 volts, and here it is 0.2 ohms, and here it is again 0.2 ohms. So here also 0.2 ohms, and this is no, not 0. Only 1 ohm. Here it is 1 ohm. Okay, so here also we can find the same way, but here just to understand the various ways that we can find, because here now again let us consider I1 to understand the various basic network reduction rules to apply. So here just I'm applying the loop analysis. Okay, so let us consider here it is let us consider this is I dash. Then instead of I1, let us consider here it is I dash. So here it is I1, the loop and loop current, and here it is, let us consider here it is I2. Okay, so then if you apply the loop analysis here, then it will become here 0.2 I1, 0.2 I1 plus again 0.2 into I1 minus I2, because the current flowing through in this direction and here it is in this direction. So I1 minus I2, which is equal to 130. This is, let us consider equation number 1. Or if you simplify this equation, then you will get 0.4 I1 minus 0.2 I2, which is equal to 130. Okay, so let us consider this is equation number 1. This is equation number 1. Then from the second circuit, here 0.2 into I2 plus 1 into I2 plus here 0.2 into I2 minus I1, which is equal to 0, right? Then if you simplify this, of course only 0.2 and 0.2, 0.4, so 1.4 I2 and minus 0.2 I1 plus 1.4 I2 equal to 0. Let us consider this is equation number 2. Then by solving equation number 1 and 2, we can get the value of I1 and I2. So by solving this equation number 1 and 2, so here you will get the I1, which is equal to 350 amperes and I2, which is equal to 50 amperes. Okay, so here this I2, which is nothing but here I dash. Okay, so now we got the one value I dash, that is the current flowing through the 1 ohm resistor, which is equal to 50 amperes, right? In the second case, case 2, so here we need to consider only the another voltage source, which is 110 volts. Then the 130 volts is replaced with short circuit. So here like this is the voltage source, and again here 0.2 ohms is there, and here 1 ohm is there. So in this case, let us consider here it is I double dash, right? So here it is 0.2 ohms, 0.2 ohms, and again 0.2 ohms, and this is 110 volts, and here it is again 1 ohm. So in this circuit now we need to find these the current flowing through this 1 ohm again. So I double dash. So again let us consider here it is loop 1, so I1, and here it is loop 2, so I2, right? And again apply the loop equations. So which means here 0.2 into I1 plus 0.2 into I2, which is equal to 110. So let us consider this is equation number 1. And equation number 2 is 0.2 into I2 plus 1 into I2 plus 0.2 into what is that I2 minus I1, which is equal to 110. Then if you simplify this, you will get here minus 0.2 I1, of course the same equation, plus 1.4 I2, 1.4 I2, which is equal to 110. So let us consider this is equation number 2. Then here by solving again the equation 1 and 2, you will get the value of I1. So here it is I1 is equal to minus 253.84 amperes, and I2 is equal to, here it is 42.30 amperes. So here I2 is nothing but I double dash, right? So now we got the value of I dash and I double dash. Then the total current flow, the current flowing through the actual circuit I is equal to, here it is I dash plus I double dash. So what is the I dash value? I dash value here it is 50 plus, and I double dash value is 42.30. So then 92.30 amperes is the total current flowing through the 1 ohm resistor, right? So here the two things that we can understand. One is, of course, for any circuit the procedure is same, okay, but when you are going for the case 1 and case 2, so here it is a simple circuit. So for that particular circuit there is no rule like you should apply only the node analysis, or you should apply only the mesh analysis, or you should apply only the current division rule or something like that. Okay, so whatever the network reduction technique that we can apply, the basic network reduction technique to find the current flowing through in each circuit. So that's why here in the first case, in the first problem I have applied the just the KCL or the nodal analysis, and in the second case I have applied the loop analysis, right? But in the both the cases almost more or less the circuit is similar, right? Then coming to the problem 3, right? So in the third problem, as you can see here, the voltage sources are in different places. Of course here also the two voltage sources only there, but here the voltage sources are placed in various places, and here we are going to use some other network reduction technique to find in each case. Okay, so here also the same way, and here also the same way, like in the first case. Okay, so case 1 we are considering only the 2 volts as active source. Then the circuit will become here so here it is the voltage source, and again resistor, and here resistor, and here one more resistor, and here again one more resistor, and this 4 volts is replaced with the short circuit. So here it is 0.1 ohm, and here it is 2 volts and 10 ohms, and here it is 5 ohms, and here it is 20 ohms, and here it is 0.2 ohms. So we have to find the current flowing through this particular circuit I. Then in the first case, let us consider again here it is what is that the I dash. Okay, then again just apply the loop analysis. Okay, so here it is one loop, and here it is another loop. So in the loop 1 the current is I1, and loop 2 the current is I2. Then when coming to the loop equation, so here again 0.1 into I1 plus 10 into I1 plus 5 into I1 minus I2, which is equal to 2. And if you simplify this here, 10, 15, 15.1, 15.1 I1 minus 5 I2, which is equal to 2. Let us consider this is equation number 1. Then coming to the second loop here, for the second loop, let us start with 20 I2 plus 0.2 I2 plus 5 into I2 minus I1 equal to 0. Then here what is I1? Minus 5 I1, and here 20, 25 and 25.2. So 25.2 I2, which is equal to 0. So this is equation number 2. Then by solving again equation number 1 and 2, then you will get the value of I1 and I2. So anyway, here we need only I2. Then I2, the value of I2 here, it is equal to 0.0281 amperes. So this I2, which is nothing but here, no, not 0.2. Yeah, we here, because it is in between. So we need I1 and I2 value. Sorry. So here I1 value, here it is 0.1417, and I2 value here it is 0.02812 amperes. Okay. Then here I dash value is I1 minus I2, because here we are considering the direction of the current is same as the direction of the direction of the current is same as the direction of the, because the direction of I is from this point to this point, and I1 is I dash is also the same way, and I1 is also the same way. So that's why we should write here the I dash, which is equal to I1 minus I2, so which is equal to 0.1158 amperes. So this is the value of I dash, right? Then next, in the second case, we are taking the 4 volts as an active source, and the remaining 2 volts source is replaced with the short circuit. So that's why here we are having only 0.1 resistor, and here 10 ohms resistor, and again here 5 ohms resistor is there. So again here the 20 ohms resistor and 2.2 ohms resistor, and here the 4 volts voltage source is there. So 0.1 ohms, and here it is 10 ohms, and here it is 20 ohms, and here it is 0.5, here it is 5 ohms, right? Here it is 5 ohms, and here it is 0.2 ohms, and here it is 4 volts. Now again, for this particular circuit, we need to find the current flowing through this particular I double dash 5 ohms. The same way, just apply the loop analysis. So in the first case, here it is 0.1 I1 plus 10 I1 plus 5 into I1 minus I2, which is equal to 0. Let us consider this is equation number 1. Then equation number 2, here it is 20 I2 plus 0.2 I2 plus 5 into I2 minus I1, which is equal to 4. Let us consider this is equation number 2. Then by solving, here it is 1 and 2, okay, then you will get here the I1 value and I2 value, right? So here the value of the I1, here it is minus 0.056 amperes, and the value of the I2 here it is minus 0.169 amperes, right? Then as we know, here the I double dash, which is equal to I1 minus I2. So here I1 is minus 0.056, and minus of I2 here it is 0.169. So then the value of I double dash here it is finally 0.1130 amperes. Then I is equal to I dash plus I double dash. Then substitute the value of I dash here. I dash here it is 0.115 plus here I double dash here it is 0.1130 amperes, right? Then here the total current I is equal to 0.228 amperes. So this is the total current. So till now we have considered only the 2 sources, but suppose if more than 2 sources, then how we can solve the problem? The same way, right? So every time we should consider only one source as an active, the remaining sources are replaced with the short circuit or the open circuit based on whether the source is voltage source or the current source, right? So then coming to the next problem here, as you can see, there are three voltage sources are there: V1, V2, and V3. So in this case, we need to find the current flowing through this 1 ohm resistor. So let us consider here it is the direction of the current for this 1 ohm is like this, right? So here first let us consider only the voltage source of this 10 volts, right? The remaining sources should be replaced with the short circuit. Then this circuit will become very simple. Here 2, and here it is again 2, and this is replaced with the short circuit, and this is replaced with the short circuit, and here it is 1, and here it is, so 10 volts, and this is 2 ohms, and here it is 1 ohm, and here it is 2 ohms again, right? The same way again here you just apply what is that, the loop analysis. Okay, so here it is I1 and here it is I2. Then the same way here let us consider here it is I dash. Okay, then in this case the circuit is the equations are very simple. Okay, so here 2I1 directly I'm writing. Okay, so 2 plus 2 4, so 4I1 4I1 plus, not plus, minus minus 2I2, which is equal to 0. This is equation number 1. And when coming to the equation number 2, here I1 only minus 2I1 and plus 1 plus 2 3, so 3I2 which is equal to 10, and this is equation number 2. Then by solving these two, here I1 which is equal to minus 2.5 amperes, and I2 which is equal to, here it is minus 5 amperes. So anyway here I dash which is equal to I2 which is equal to how much? Yeah, minus 5 amperes. So this is the first case, right? Then coming to the second case, we are just considering the middle what is that, voltage source. Okay, so again here it is 2 and here it is 2, and in between this particular branch having the voltage source also, and here it is 1, and the other voltage sources are replaced with the short circuit. So here it is 2 ohms and 1 ohm, and this is 2 ohms, and again this is 6 volts. So here also the same way, apply the loop analysis. Let us consider here it is I1 and here it is I2, and in this case here it is, let us consider I double dash, right? The same thing here also, what is 2 plus 2, so 4. Okay, 4 into I1 minus 2 I2 which is equal to 6. Okay, and in the second case again only I2 here, yeah, minus 2 I1 plus 2 plus 1 3 I2 which is equal to 6. So again let us consider this is equation number 3 and this is equation number 4. So by solving these two equations, then you will get I1 which is equal to minus 0.75 amperes, and I2 which is equal to 1.5 amperes. So here this I2 which is equal to I double dash which is equal to 1.5 amperes. So this is the second case, right? Then similarly, in the third case, we should consider only the one voltage source. Here it is this, and let us consider here it is case 3. So same 2 ohms, and here also 2 ohms, and here it is 1 ohm, and of course this is also replaced with a short circuit, and here it is 2 ohms, and what is the voltage source value? Here it is, yeah, 8 volts, and here it is 2 ohms and 1 ohm. Then here again let us consider here it is I triple dash. So the same way here it is I1 and here it is I2, and write the equation. So here let us write the equation. So 2I1, not 2I1, 4I1 minus 2I2 which is equal to 8. This is equation number 5. And similarly in the second case also, yeah, minus 2I1 plus 3I2 which is equal to 0. Let us consider this is equation number 6. Then by solving these two equations, you will get I1 is equal to 3 amperes and I2 is equal to which is equal to 2 amperes. So here I2 is equal to I triple dash which is equal to 2 amperes, right? So now the total current I is equal to I dash plus I double dash plus I triple dash, because here three sources are there. Okay, so what is the value of I dash that we have calculated? Minus 5 amperes minus 5 plus here I double dash is 1.5 and I triple dash here it is 2. So which means here the value is the value of this particular thing is minus 1.5 amperes. Okay, so which means actually we have considered the direction is like this. Okay, but which means here the direction is like this, but if you want to if you want to replace as a positive current, then 1.5 amperes, the direction is like this. Okay, because here the negative sign indicates just the direction. We are getting the negative current means whatever the current that we are considering as a reference current, so the exact opposite is the actual current direction. So that's why we got the negative sign, right? So this is how to find to apply the superposition theorem. Then finally we just need to I want to consider one more problem. So here one more thing, just one thing we need to understand, one more concept is there here. Okay, I mean then in this case also we are having the three voltage sources anyway. Okay, but in each case we have to consider again one voltage source, and the remaining two voltage sources are replaced with the short circuit, right? So first let us consider here only the 10 volts voltage source. Okay, so when coming to the 10 volts voltage source here, as you can see, the case 1 here it is 10 volts. So then the equivalent circuit here this is 10, and again this is 10, and this is 1. Of course this is again replaced with short circuit. Of course 8 amperes is there and 20 ohms is there, right? So here it is 10 volts and 10 ohms, 1 ohm, and of course here again short circuit we are replaced 8 ohms and 20 ohms. So here these 12 volts is make it as a short circuit, then the resistor is connected in parallel to the short circuit is become 0, the resistance value. So that's why here we should neglect, because the short circuit having very very small resistance. Okay, so it can be negligible, so that's why here we should neglect this one also. Then the equivalent circuit will become here only having these things 10, and here again one more 10 and 1 and 20. Only these are the things that we are having. So here it is 10 ohms, and here it is 1 ohm, and here it is 20 ohms, right? Okay, so there are many ways to find here what is that the current, because here where we need to find the 20 ohms. So here we need to find in this circuit, let us consider I dash. So here it is I. Okay, so let us consider with because now here the total current I is equal to, let us consider here the current flowing through here it is not here. Okay, then here I dash. So let us consider here it is I. So I is equal to the voltage here it is 10 by, as you know, these two are in series, and the series combination is parallel with the 10. So which means what is the 20 which is 21. So 21 into 10 by 21 plus 10. So this is the total current I. And again let us consider here it is suppose if you know the value of I, then the I dash which is equal to the total current here it is I into the opposite resistor. Okay, what is the opposite resistor value? Here it is 10 by 10 plus 1 plus 20. So by using this you can find here the I dash value. Then the value of the I dash here it is the value of I dash here it is 0.476. This way we can find the value of the I dash, right? This is another way to find the value, because of course all the circuits in all these problems are almost similar, but sometimes we have applied the KVL and sometimes we applied the KCL, but here instead of KVL and KCL I have applied the current division rule, right? Then in the second case we are applying, I mean we are considering only 8 volts source. Okay, so which means again here if you make it this one as a short circuit, then this resistor will be also negligible. So now we are considering only these 8 volts voltage source. So this is, let us consider here it is case 2. So then in this case you will be having only this what is that, 20, because here yeah, this is short circuit and this is short circuit. So this resistor will become 0, then you will be having only these 1 ohm and 20 ohms resistors, right? So that's why here you will be having only 1 ohm and 20 ohms resistor. Okay, yeah, here you are having only this is 20 ohms and this is 1 ohm and this is 8 volts. Then here it is, let us consider I double dash. So here it is very simple. I double dash is equal to the total voltage V by 1 plus 20. So then which is equal to minus which is equal to, of course, in the same way, the same direction, if you consider here it is which is equal to 0.3809, right? So this is the value of I double dash, right? Then in the third case, of course, only this source we must consider, okay, and all other remaining sources we must neglect. Then the circuit will become like this. So here it is 1 ohm and here it is 12 volts and here it is 8 ohms and here it is 20 ohms. Okay, then again here you will be having two loops, loop 1 and loop 2. Okay, let us consider here it is I1 and I2. Okay, then again by just to apply simple loop analysis, then you can find the value of I1 and I2. So here the value of I2 which is equal to minus 0.571. Okay, so now which is nothing but I triple dash which is equal to minus 0.571. Then I is equal to, again here also, I dash plus I double dash plus I triple dash. Okay, I is equal to I double dash plus I dash plus I triple dash. Then which is equal to the value, I mean now the total, if you substitute I dash, I double dash, I triple dash from the equations that we got, then finally I is equal to 0.476 amperes. So this is the value that we got, I is equal to. So this is the way we can solve the various problems. Of course, one more problem is also there here. So here it is very simple. Okay, so which means here in the first case, let us consider only one source. This is very simple problem. So here it is only the 6 ohms resistor is there. So this is 20 volts and here it is 5 ohms and here it is 3 ohms and here it is 6 ohms. Okay, then here you just apply the current division rule, then you can get directly the current value. Okay, so which means again let us consider where we need to find 3 ohms resistor. So here we need to find then I dash. Okay, so apply any kind of rule, then you will get the value of I dash. So here I dash that you will get here it is 1.904 amperes, 1.904 amperes. Then similarly here the second case, here it is this is the second case. So here 5 and 3 and 6 and 40 volts. So again here it is, let us consider I double dash. So here also you can apply any one rule, then I double dash, here you will get the value of I double dash, here it is 3.174. okay, then again we know I is equal to I dash plus I double dash. So to solve this I dash and I double dash, you can apply, one is what is that, KVL. Okay, second one is KCL and the third one is the current division rule. So by using any one of these three methods, okay, so you can find the value of I dash and I double dash, right? So this is how about the superposition theorem. So you can what is that, apply any kind of network. I mean the network, if the network should have more than one active source, okay, either it may be voltage source or current source, then only we can apply the superposition theorem. Otherwise, if it is only single source, so we can't apply the what is that superposition theorem. So that is the only condition to apply the superposition theorem to find the response across any element. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.